The discovery does not begin with fire. It begins with cold. Not the familiar cold of winter air or polar oceans, but a planetary cold, so deep it could make a world that looks like Earth feel more like a frozen warning. Out in the dark, around 146 light-years away, astronomers have identified a possible rocky planet orbiting a star that resembles the Sun. Its name is HD 137010b. From a distance, it appears to carry the profile scientists have been searching for. Slightly larger than Earth, circling a sun-like star, moving on an orbit that may last almost exactly 1 year, and sitting close enough to the right distance that liquid water could, under certain conditions, exist. For a moment, the image is almost comforting. Another Earth-like world, another familiar rhythm, another place where life might seem possible. Then the temperature arrives like a sentence. Because this world, despite the resemblance, may be colder than Mars. That is the tension at the heart of the discovery. HD 137010b is not being introduced as a lush twin of Earth glowing beneath a golden star. It is being introduced as a candidate suspended between promise and punishment. The planet may lie just inside the habitable zone of its host star, the narrow orbital region where surface water can remain liquid if the atmosphere is right. But the star itself, though similar to the Sun, is cooler and dimmer. It sends far less energy outward. The result is brutal. Scientists estimate that the planet may receive less than 1/3 of the heat and light Earth receives from the Sun. Under those conditions, the surface temperature could sit near -90 degrees Fahrenheit, or -68 degrees Celsius. That is not a gentle world. That is not a forgiving world. That is a landscape where even Earth-like geometry can hide planetary death. And this is what makes the discovery so unsettling. The universe may be presenting a world that looks correct from afar, while being fundamentally hostile up close. Same kind of star, similar orbital timing, rocky composition, a place that, in a simplified diagram, could be mistaken for a second chance at Earth. But the numbers shift the mood immediately. A near-Earth year does not guarantee a near-Earth climate. A habitable zone does not guarantee habitability. Similarity is not safety. So the announcement lands with a chilling question. What if the next Earth-shaped world humanity finds is not alive, not warm, not blue, but frozen solid beneath a sky that never had enough light to save it? What scientists found is not a confirmed planet yet, and that uncertainty only sharpens the story. HD 137010b is still classified as a candidate, not because the signal was weak, but because the entire case rests on a single passing shadow. The evidence came from Kepler's second life, the K2 mission, long after the telescope had already transformed humanity's map of the galaxy. Even after Kepler stopped operating in 2018, its archived data continued to yield new worlds, as if the mission had gone silent but refused to stop speaking. Somewhere inside that old stream of starlight, astronomers caught one 10-hour dimming event, one small object crossing the face of a bright, nearby, sun-like star. One transit, one eclipse on a miniature scale, one momentary interruption in the light. And from that brief interruption, an entire possible world emerged. The star involved, HD 137010, sits close enough and shines brightly enough to matter. That detail is not cosmetic. It changes the level of scientific tension completely. Many exoplanets are found around stars too faint, too distant, or too noisy for meaningful follow-up. But this system is different. If HD 137010b proves real, it may become the first Earth-like transiting planet around a sun-like star, close and bright enough for serious future study. That turns the discovery from a catalog entry into a target. Not just another point on a chart, but a world that observatories could pursue, test, and interrogate. A world that may force astronomy to ask an uncomfortable question. How many planets can resemble Earth in structure while failing it completely in climate? Even the orbital estimate reads like a cosmic mirror with something wrong in the reflection. Based on the duration of that transit and the geometry of the system, the planet's year may be roughly comparable to Earth's. The transit itself lasted around 10 hours. Earth, seen from far away crossing the Sun, would take about 13, so the proportions seem hauntingly familiar. The scale is close, the timing is close, the architecture is close, but the energy budget is not. The star is cooler. The star is dimmer. The orbit may mimic Earth's calendar, while the surface descends into a temperature regime more severe than the average face of Mars. That is where the discovery stops being merely exciting and starts becoming unnerving. Because this is not a world that advertises its danger openly. It hides inside resemblance. It uses the language of habitability while standing on the edge of permanent freeze. And with only one transit scene, the planet remains trapped in scientific suspense, visible enough to disturb the imagination, but not yet solid enough to fully trust. The danger deepens when the physics are stripped of romance. Habitability is often imagined as distance. Too close and a planet burns, too far and it freezes. Basadi 137010b exposes how deceptive that picture can be. A world can sit near the edge of the so-called habitable zone and still be locked in planetary cold if the star feeding it is too weak. This star may resemble the Sun in type, but resemblance is not equality. It is cooler. It is dimmer. And that means the light reaching the planet could be so limited that the surface, left to simple radiative balance, falls to around -90 degrees Fahrenheit. That is colder than the estimated average surface temperature of Mars. So the threat is not dramatic impact, tidal destruction, or stellar eruption. It is something quieter and, in some ways, worse. A world built in the silhouette of Earth, but starved so completely of warmth that the basic chemistry of comfort collapses. On a planet like that, the environment would not merely be difficult. It would be structurally hostile. Liquid water, if it appeared at all, would depend on an atmospheric rescue mission. Without a thick enough blanket of greenhouse gases, surface water would lock into ice, thermal cycling would weaken, and the planet's visible similarity to Earth would become almost cruel. The same broad category of rocky planet, the same approximately yearly orbit, the same alignment that lets it pass across its star from humanity's point of view. Yet all of it could exist above a frozen crust under a sky lit by a weaker sun. A planet can look eligible for life on paper while physically trending toward silence. And still, the uncertainty remains dangerous in its own way, because the models leave a narrow door open. Researchers suggest that if HD 137010b possesses an atmosphere much richer in carbon dioxide than Earth's, conditions might shift. Enough greenhouse trapping could push the climate upward, perhaps even enough for liquid water to persist in some stable form. That possibility is why the planet has not been dismissed as a dead world. Modeling suggests it may have a meaningful chance of falling within the conservative habitable zone, and an even greater chance within a broader, more optimistic definition. But that same analysis carries the opposite verdict inside it. The world may also lie outside true habitability altogether. This is where the fear becomes scientific rather than speculative. HD 137010b may not be a paradise hidden in the cold. It may be the clearest example yet of how thin the line is between Earth-like and unlivable. What makes HD 137010b especially haunting is not just the cold itself, but how difficult it will be to prove what the cold means. The planet was inferred from a single transit, one passage across the face of its star. That is enough to raise a signal, enough to estimate size and orbit, enough to build a terrifying possibility. But it is not enough to settle the case. Astronomers need repetition. They need the planet to cross again and again at the expected interval, so that the shadow becomes a pattern instead of an accident. Without that repetition, even one of the most intriguing Earth-like candidates can remain suspended between reality and illusion. And HD 137010b does not make confirmation easy. Because if its orbit truly is similar to Earth's, then its transits are rare by definition. A planet close to its star reveals itself often. A planet moving on a near year-long path hides for long stretches of time. It gives science only brief chances to catch it in the act. Miss the window, and the darkness closes again. That is one of the cruelest laws in exoplanet hunting. The worlds most similar to Earth are often the hardest to detect, not because they are invisible, but because they are patient. They cross infrequently. They demand precision. They force astronomers to wait through cosmic silence for another shadow that may last only hours. So the threat here becomes something larger than climate. It becomes epistemological. Humanity may have found a world that sits at the edge of habitability, a rocky planet around a sun-like star, bright and nearby enough to matter, and still remain unable to fully grasp it for years. The successor instruments, NASA's TESS, ESA's CHEOPS, and the telescopes that follow, may eventually pin it down. They may confirm the orbit, constrain the radius, test the atmosphere, and determine whether this is truly a frozen Earth-like world or a planet barely saved by greenhouse warming. But until those observations arrive, HD 137010b exists in a kind of scientific twilight, close enough to disturb, distant enough to evade, familiar enough to tempt, and uncertain enough to remain dangerous. That uncertainty is not comforting. It is the hidden danger inside the discovery. A world can be close enough to imagine, real enough to fear, and still remain just beyond the reach of proof. And in that gap between detection and confirmation, the universe reveals something unsettling about itself. The planets that matter most may not announce what they are. They may flicker once, then vanish back into the light. In the end, HD 137010b is frightening for a reason that goes beyond temperature. It threatens one of humanity's most comforting assumptions about the search for life, that if a planet resembles Earth closely enough, hope naturally follows. This candidate world seems to challenge that instinct at every level. It may be rocky. It may be only slightly larger than Earth. It may orbit a star much like the Sun. Its year may echo our own. It may even sit within the zone where liquid water is theoretically possible. Yet all of those familiar features can still assemble into a planet where the surface is cold enough to rival or undercut Mars, where water may freeze unless the atmosphere performs a precise act of rescue, and where the line between life-supporting and lifeless may depend on invisible gases wrapped around a distant globe no human being will ever touch. That is the true scale of the discovery. Not a second Earth. A warning about how easily Earth can be imitated. Because the universe does not build safety from resemblance. It builds variations. Some of them are beautiful from afar and fatal up close. HD 137010b may become one of the most scientifically valuable exoplanets ever found precisely because it sits so close to the edge. If follow-up observations confirm it, astronomers will not just be studying another rocky world. They will be studying a planetary test case for habitability itself. How much warmth is enough? How much atmosphere is required? How thin the margin really is between a living world and a frozen one. And every answer may narrow humanity's understanding of its own place in the cosmos. That is why this discovery feels larger than one candidate planet. It forces a colder interpretation of the night sky. Somewhere out there may be countless worlds that look right in silhouette and fail in substance. Worlds with Earth's rhythm, Earth's scale, Earth's geometry, yet none of Earth's mercy. Worlds that circle obediently through darkness, carrying the structure of possibility without its outcome. The more astronomy learns to recognize those worlds, the more unsettling the universe becomes. Not because life is impossible, but because the appearance of life may be common while the conditions for it remain brutally rare. So HD 137010b hangs in the dark as both invitation and verdict. A planet that may sit in the habitable zone and still freeze. A planet that may resemble home and still reject it. And that may be the most disturbing lesson of all. In this universe, being almost like Earth may still mean being nowhere close enough to survive.